Take a breath and picture a ship somewhere in the gray water between Greenland and Iceland, in a place where the sea is nothing but sea. There is no island here, no landmark, nothing to see in any direction but the same slow swell moving under the same low sky. And the crew are doing something that, from the outside, looks almost like a burial at sea. They are lowering a long wire over the side. Down it goes into water more than half a kilometer deep, and clamped along that wire at intervals are instruments, current meters, sensors that taste the temperature and the saltiness of the water. They pay it out until it hangs in the dark like a plumb line dropped into the body of the ocean. And then they anchor it. And then they leave. Not for an hour, not for a day. For a year. Nobody watches it. Nobody could. It hangs there in total blackness, in water just above freezing, through the long Arctic winter and the brief gray summer, while the instruments do the one thing they were built to do. They listen. They record what the water is doing, second by second, all the way through the dark. And when the ship finally comes back, a year older, and hauls that wire up out of the deep, and the scientists sit down to read what the meters wrote, they find something recorded there that has no business being in the middle of the open ocean. In a place where the water's supposed to just sit there, being ocean, the wire has logged a colossal, continuous, downward flow. A river running through the sea. Water falling, you have never seen it. No one has ever seen it. No camera ever will. But the wire is certain. There's a waterfall running through the dark between Greenland and Iceland right now, this second, and it is the largest waterfall on planet Earth. Not Niagara, not Angel Falls, not any of the great cataracts you could name, the ones with visitor centers and viewing platforms and rainbows in the spray. The biggest one on the whole planet is down there, silent, invisible, colder than ice water, and it has been falling continuously. Not for years, not for centuries, for thousands of years. And here's the part I keep turning over in my head, the part that changes what this whole thing is about. It isn't just a curiosity. It isn't just the world's strangest bit of trivia. That invisible waterfall is a working part of the machine that decides what the weather is like where millions of people live. Your weather, quite possibly, leans on it, and almost nobody knows it's there. I want to tell you how we found it, and how it works, and why the honest version of this story is stranger than the version you'll see in a headline. But first I have to tell you the thing I'm not going to be able to prove to you the way you'd want me to. Because that's the whole point. There is no single famous book behind this one. I went looking for it. The one science writer who cracked this open, the Eureka scene, the lone genius on the deck of a ship shouting that they'd found it. And I couldn't find that story, because that story mostly doesn't exist. What exists instead is better and quieter and much harder to film. What exists is a record. A long, patient, unglamorous record, built by people leaving wires in the deep and coming back a year later to read them, doing it again and again since the 1990s. The load-bearing piece of real science under everything I'm about to tell you is a study published in 2017 in a Journal of Ocean Research, with the deeply unromantic title of a revised transport estimate. And I know revised transport estimate is not a phrase that quickens the pulse. But sit with what it actually means. It means that as recently as 2017, we were still correcting our best guess about how much water this thing moves. We are still, right now, refining the measurement of the largest waterfall on Earth. That's how young our knowledge of it is. That's how hard it is to know a thing you can never look at. So this isn't a story about a person. It's a story about an instrument. The true main character here is that wire hanging in the dark, and the year of silence it records and the strange trace it brings back up. Hold on to that, because everything that makes this beautiful and everything that makes it unsettling comes from the same root, that the biggest waterfall on Earth is a thing we can only know by inference. We don't see it. We deduce it. Like a doctor who never once lays eyes on your heart but reads the jagged line an ECG draws on a screen and tells you with total confidence exactly what the muscle in your chest is doing. We are reading the ocean's ECG, and the trace says waterfall. Let me take you back to the ridge itself, because to understand why water falls here, you first have to understand the shape of the ground it falls over, even though no human eye has ever taken in that ground the way you'd take in a mountain. The Denmark Strait is the gap between Greenland and Iceland. On a map, it looks like a channel, a stretch of open water maybe 480 kilometers across. What the map doesn't show you is the floor. Because running across that gap, down in the dark, there is a ridge, a raised lip of seabed, a threshold sitting at a depth of around 600 meters. Oceanographers have a plain word for a ridge like this. They call it a sill. And a sill does exactly what the word suggests. It's a doorstep. It's the raised edge you'd step over to get through a doorway, except this one is submerged, and it runs for hundreds of kilometers between two of the coldest coastlines on Earth. Now, here's what matters about that doorstep. On the northern side of it, up towards the Arctic, sits water that is intensely, brutally cold. Water that formed in the frozen Nordic and Arctic seas, chilled to just above freezing. And cold seawater is heavy. It's dense. On the southern side of the sill sits Atlantic water, warmer and lighter. So you have this situation, held in place by a single ridge of rock and sediment, a great mass of the heaviest water in the ocean, sitting up against a threshold, and just on the other side of that threshold, a drop into the deep Atlantic. The heavy water is leaning on the door, and gravity does to a heavy fluid exactly what you'd expect it to do. It pours over the lip, it spills. The dense Arctic water reaches the top of that submarine sill, and it pours over the edge and it sinks, sliding down and underneath the warmer, lighter water on the far side, running downhill along the seafloor into the black depths of the North Atlantic. That's the waterfall. That's the whole thing, mechanically. Heavy water, a threshold, a drop, and gravity. The oldest machine there is. Think about the cold air that falls out of an open freezer. You felt it. You open the door, and that heavy, chilled air spills down over the lip of the freezer and pools around your feet, tumbling toward the floor. You can't see it. There's no color to it, no edge, no line where the cold air stops and the warm kitchen begins. But it's real, and it's moving, and it's falling. Because cold air is heavy air, and heavy things fall. Now, make that freezer the size of a strait between two countries. Make the cold air the coldest water in the ocean. Make the floor the abyssal plain of the Atlantic 3 kilometers down. That's what's happening between Greenland and Iceland, second after second after second, in the dark. But I've skipped the hardest part, which is how anyone came to know this at all. Because you cannot see it. That freezer air is invisible in your kitchen even with the lights on. This thing is invisible in the deepest dark there is. So how do you find a waterfall you can't look at? You leave the wire. And you wait. Currents across the Denmark Strait have been monitored with moored instruments since 1996, machines called acoustic current profilers, which sit in the deep and use sound to measure the water moving past them, along with simpler rotor meters that spin in the flow. And in the summer of 2014, a fuller array went in. A set of these profilers and current meters lowered across the strait, anchored, and left through an entire year until they were recovered in the summer of 2015. A year of the ocean's pulse, written down in the dark by machines nobody was watching. I want you to really feel how strange that method is, because we don't normally think about knowledge working this way. When we found the tallest mountain, we climbed it, or we surveyed it with lines of sight and angles. When we mapped a coastline, we sailed it and drew it. Our whole instinct for discovery is built on the eye. Go there, look, record what you see. But you cannot go and look at this. There is no there to go to that your eyes could resolve into anything. The only way to know it is to place a machine in the blackness, walk away, let it feel the water for a year, and then read the story it wrote. Discovery here isn't a moment of seeing. It's an act of faith in an instrument, redeemed a year later by a page of numbers. And when they read those numbers, here is what the numbers said. The amount of dense water pouring over that sill, over the doorstep, is measured in a unit oceanographers use for the truly enormous flows, the sverdrup. One sverdrup is 1,000,000 cubic meters of water every second. Say that slowly. 1,000,000 cubic meters, a cube of water 100 meters on every side, moving past you every single second. And the measured flow of this overflow water across the sill is somewhere around 3 to 3.5 of those. 3.5 million cubic meters of the heaviest water in the ocean, tipping over that submarine ledge every second and sinking into the deep. The best single figure from that year-long array came out at around 3.5 sverdrups, give or take a little. And I want to be honest with you that the give or take is part of the story, not a footnote to it. This is a measured thing, with an error bar, from real instruments in real water. It is not a number someone made up to sound impressive, and that year of measurement resolved something beautiful too. The overflow isn't one single stream. The instruments could see that it's fed by 2 rivers of cold water braided together, a broad, powerful current running down the east coast of Greenland, carrying the larger share, and a second, narrower jet flowing along the north of Iceland, carrying less but still feeding the fall. 2 frozen tributaries, meeting at the doorstep, pouring over together. Nobody drew that on a whiteboard from theory. The wire found it. Now, if you've heard of this waterfall before, you've probably heard a bigger number than 3.5 million. You've probably heard something like 5 million cubic meters a second. And that number is real too. But it's measuring a different moment in the fall, and the difference between those two numbers is one of the most honest and interesting things about this whole phenomenon. So let me not paper over it. Here's what happens after the water pours over the sill. As that dense cold plume sinks and slides downhill into the deeper basin south of the strait, it doesn't fall cleanly and alone. It drags. A sinking mass of water pulls the surrounding water into its motion, sweeping it along, so the plume grows as it descends. Oceanographers call this entrainment, the falling water entraining, gathering the water around it. So the flow that starts as roughly 3.5 million cubic meters a second at the top of the fall has swollen to something like 5 million by the time it's well down into the deep basin below. Both numbers are true. One is the water going over the lip, the other is the water once the fall has bulked itself up by hauling its neighbors down with it. When you see 5 million cubic meters per second, that's the second number, the fall after it's grown. I'd rather you hold both than harden one of them into the whole truth. Picture pouring a stream of cold dyed water gently into a tall glass of warm, clear water. The dyed water doesn't mix and disperse. It slides straight to the bottom in a smooth, coiling sheet, and as it goes, it tugs a little of the clear water into its curl. That tug, at the scale of an ocean, is millions of cubic meters a second of extra water joining the fall. The plume arrives at the bottom bigger than it left the top. And now, take away the dye, make both waters clear. That's the real thing. A colossal falling sheet of water, gathering more water as it drops, and not one particle of it visible to any eye. So we have the flow. Now the drop, the height of this fall. And here I have to slow down and be careful with you, because this is exactly the kind of number that travels around the world without its hedges attached. The cold water, once it goes over that sill, sinks a very long way down. The figure you'll see quoted is a fall of more than 3.5 kilometers, around 11,500 feet. The most authoritative popular description of it, from the American Ocean Service, puts it as a fall that begins around 2,000 feet below the surface and plunges down to something like 10,000 feet. And the comparison that always gets reached for is the tallest waterfall on land, Angel Falls in Venezuela, a genuine visible roaring waterfall that drops around 979 meters, a little over 3,000 feet, off a sheer cliff in the jungle. Set the two side by side, and this underwater fall is roughly 3 times taller than the tallest waterfall that exists on dry land anywhere on the planet. But I want to be straight with you about that 3.5 kilometers, because honesty is the only thing this channel has that's worth anything. That height is an approximation. It's a widely repeated, reasonable order of magnitude figure, not a surveyed to-the-meter measurement like the height of a cliff you could stand on. What's genuinely, solidly established is that there's a very large vertical fall here. The dense water demonstrably sinks from near the sill down into the deep Atlantic, thousands of meters. The exact 3.5 is a rounded estimate that different sources render slightly differently. So when I say 3 times Angel Falls, hear it as the vivid, roughly true comparison it is, and not as a claim that someone stretched a tape measure down the side of this thing. Nobody has. Nobody could. And even the comparison itself, honestly, is only skin deep. It's a comparison of height and nothing else. Because Angel Falls in this thing work by completely different physics. Angel Falls is water falling through air off a rock cliff. This is water falling through water down a slope of density. They share a number and almost nothing else. Which brings me to the strangest beat in this whole story. The one I've been circling, the one that's the real reason I couldn't stop thinking about it. Not the size, the invisibility. Why can't you see it? Not, why is it too deep to see? I mean, even if you were there, in a submersible, with the most powerful lights ever built, hovering in the exact spot where 3.5 million cubic meters of water are pouring over the ledge every second, you would see essentially nothing. You could pass straight through the largest waterfall on Earth, and your eyes would report calm, dark, ordinary sea. Here's why. Go back to Angel Falls or Niagara or any waterfall you've ever stood near. Why can you see it? You can see it because the water is falling through air. Water and air are wildly different. One is roughly 800 times denser than the other. So where they meet, you get a sharp, violent boundary. The falling water shatters against that boundary into droplets and spray and white foam. It aerosolizes, it catches the light, it roars. The whiteness of a waterfall is water being torn apart by its collision with air. That's the whole visual spectacle, a density difference so enormous that the water can't hold together. Now, look at the Denmark Strait Cataract. The water that's falling is cold seawater. The water it's falling through is slightly warmer seawater. Both are seawater. The density difference between them, the very thing that drives the entire fall, is tiny. There's no huge contrast to create a sharp surface. There's no air to shatter the water into spray. There's no boundary crisp enough for light to catch. The falling water and the water it falls through blend at their edges into the same dark medium. So there's no white curtain, no foam, no plunge pool, no roar. There is a mountain range of water falling 3 kilometers through the deep, and it makes no sound you could hear and shows no face you could photograph. Its existence, all of it, is inferred purely from the temperature, the saltiness, and the motion that the instruments record. Take the instruments away, and it is, in the most literal sense, undetectable. The Ocean Service's own words for it are that it would go completely undetected without the aid of scientific instruments. Let that sink in, because it's a genuinely disorienting thought. The single largest waterfall on the face of the Earth is, in the ordinary meaning of the word, invisible. It has never been filmed. It has never been photographed. No one has ever dived it or seen it or heard it. Everything we know about the biggest waterfall on our planet, we know the way you know a word you can't quite read on a page held just too far away, by every indirect means except looking straight at it. I keep coming back to the doctor and the ECG. You never see the heart. A trace crawls across a screen, a jagged line drawn by a machine reading electricity through the skin, and from that line, just that line, a good cardiologist will tell you the heart is racing or skipping or failing with a confidence they'd stake your life on. They're not guessing. They're inferring from an instrument a truth about a thing they will never lay eyes on. That is precisely exactly our relationship to this waterfall. We have the ocean wired to a monitor. We read the trace. And the trace is unambiguous, because this invisible waterfall is not a curiosity sitting off in a corner of the ocean, minding its own business. It is a working component of a machine that spans the entire Atlantic. And that machine is part of the reason a whole region of the world is warm enough to live in comfortably. Let me build this carefully, one piece at a time, because it's the heart of the whole thing, and it's also the place where bad science channels go to die, so I'm going to be scrupulous. The dense water that pours over the Denmark Strait sill has a name, Denmark Strait Overflow Water. And it has a destiny. Once it's fallen into the deep Atlantic, it doesn't just pool at the bottom and stop. It becomes the densest, deepest ingredient in a vast, slow, planet-scale current. Because the ocean is not a still bath, it turns over. Warm, light water rides north near the surface, cold, heavy water sinks and flows south along the bottom, and the whole thing loops endlessly, like a conveyor belt laid across the floor of the Atlantic. Scientists call that overturning circulation, the Atlantic meridional. Overturning circulation, a mouthful I'll only say once and then set aside. Call it the conveyor. And the cold water sinking over the Denmark Straitsil is one of the primary things that feeds the deep southbound bottom half of that conveyor. Our invisible waterfall is one of the pumps in the ocean's basement. Now, why does a pump in the basement matter to you up in the daylight? Because of what the conveyor carries. As it hauls cold, dense water south along the deep, it draws warm surface water north to replace it. And that warm surface water, riding north across the Atlantic, carries heat, an immense continuous transport of warmth from the tropics up toward the high latitudes. It's a central heating system for a continent, and the northern edge of Europe sits directly in the path of that warmth. Here is the fact that makes it visceral. Take Britain, mild green hedgerows and drizzle, rarely truly frozen. Now find Britain's latitude and follow that same line of latitude straight across the Atlantic to the other side. You land on Labrador, in northern Canada. Same distance from the equator, same amount of sunlight, near enough, over the year. And Labrador has sea ice. Labrador has polar bears. One of these places is temperate farmland and the other is subarctic wilderness, and they sit on the same line around the globe. Part of what separates them, part of why the northeast side of the Atlantic is so much gentler than the northwest, is that ocean heat riding north on the conveyor. And one of the pumps driving that conveyor is the silent waterfall pouring over the sill between Greenland and Iceland right now in the dark while you go about your day. Something the size of a mountain range is falling through the ocean where no one can see it, and the mildness of an entire region's climate leans in part on it continuing to run. Now, and this is important, this is exactly where I have to slow down and be honest rather than dramatic. I need you to hear what I am not saying as clearly as what I am. Because the temptation here, the thing every clickbait version of this story reaches for, is the doom. The "if this stops, Europe freezes" segment with the dramatic music and the map of Britain turning white. I'm not going to give you that, and I want to tell you plainly why. It's true that scientists watch the North Atlantic circulation closely. It's true that whether that great conveyor might weaken in the future is a genuine, active, serious area of research. But the timelines, the probabilities, the will it, won't it, when, those are heavily contested. They are not settled. And the honest scientific position is not a forecast of collapse, it is careful monitoring and open questions. Anyone who tells you they know that Europe is about to freeze on a date is selling you fear, not science. So here's the whole of what I'll say, and I'll say it once, cleanly. The overflow is a real and important component of the ocean's northward heat transport. Changes in the North Atlantic are watched more carefully than almost anything else in oceanography. And beyond that, the responsible answer is that we are still finding out. The dread in this story was never supposed to come from a catastrophe. It comes from something quieter, and to me, far stranger, that a structure this enormous, this consequential, was running the whole time, in total silence, and we had no idea because we were waiting to see it. And I should be fair to the skeptics on the warming too, because this channel doesn't cheat. It's an oversimplification to say the ocean alone keeps Britain warm. The atmosphere matters enormously. The prevailing winds, the way air circulates across the Atlantic, all of it plays a part. The ocean's heat transport is a piece of the story, an important piece, not the entire explanation. So when I draw that line from Britain to Labrador, hear it as one real factor among several, not a single lever that one waterfall pulls by itself. I promised you I'd steelman the doubters, and there's a deeper objection I want to give real room to, because I think it makes the story better rather than worse. It's this: is waterfall even the right word? Because a lot of oceanographers would wince at it. They'd tell you correctly that there's no free surface here, no air, no plunge, no falling in the everyday sense, and they'd prefer to call it an overflow or a density current and leave the word waterfall to the tourist attractions. And you know what? I think they have a point, and I think the honest version they're pushing toward is actually the more astonishing one. Because a waterfall is a thing you've seen 100 times, but a silent density current the size of a mountain range, sliding invisibly down a slope of the seafloor, detectable only as a change in temperature, and salt on a wire left in the dark for a year, that's not something you've seen. That's something genuinely new. The metaphor of the waterfall is a doorway. What's on the other side of the doorway is stranger than the metaphor, and I don't want the word to flatten it for you. Let me put the physics as plainly as I can, stripped of every technical word, because the mechanism is the beautiful part, and I don't want it hidden behind jargon. Seawater gets heavier when it gets colder, and when it gets saltier. North of the strait, the water is both very cold and salty enough to be extremely heavy. It sits up against the sill. Gravity pulls down on it, the way gravity pulls down on anything heavy, and where the sill gives it an edge to spill over, it spills, pouring down the far slope and sliding underneath the lighter water in its way, because heavy fluid always sinks beneath light fluid. That's it. That's the engine. There's no mystery machinery, no exotic force. It is the same physics as the cold air off the freezer, the same physics as cream sinking through coffee, the same physics as a stone dropped in a pond, a heavy thing in a gravity field going down. The only trick is the scale, and the fact that both the heavy thing and the medium it falls through are made of the same stuff, so the whole event happens without a single visible edge. And once you've seen that, once you've really got hold of the idea that a small difference in density, spread across a large enough scale, can move an ocean, you start seeing it everywhere. Because that's the thread I can't stop pulling. This waterfall is not a freak. It's one visible to instruments instance of a rule that runs the entire planet. The same rule, heavy fluid sinks beneath light fluid, doesn't just make one waterfall between two islands. It runs the whole ocean, every basin, every sea, all around the planet. In cold places where surface water chills and grows heavy, water is sinking, and elsewhere water is rising to take its place, and the whole world ocean is turning over in one enormous connected loop that touches every coast on Earth. The Denmark Strait Fall is simply the single most concentrated, most dramatic instance of it. The one spot where the sinking is so sharp and so channeled by a ridge that it earns the word waterfall. But the physics doing it there is the same physics doing it, more gently, more diffusely, across the entire globe. There's a machine spanning the whole planet, moving water and heat on a scale that dwarfs every river system combined, and it has no visible surface anywhere. Not one part of it is a thing you could stand and watch. And that's the pattern that unsettles me more than the size of any single fall. Think about how much of the world that actually governs your life is like this, knowable only by instrument, never by eye. The overturning of the oceans hidden in the deep, the slow churning of the rock deep inside the earth, the heat moving in the mantle beneath your feet that shifts continents over millions of years, also invisible, also inferred, also known only from traces read on instruments. The biggest engines driving the surface world we live on mostly run out of sight, below the threshold of anything a human being could ever look at directly. We are surface creatures. We evolved to trust our eyes, and the machinery that matters most is, almost as a rule, underneath, in the deep water, in the deep rock, in the dark. A small density difference, acting over a large enough scale, moves oceans and moves continents. And we find these things not by seeing them, but by measuring what we will never see. There's a scale of time here too that I have to be careful with, because it's easy to reach for a number that sounds grand, and it's better to be honest about what's solid. What is solid is this. The overflow over the Denmark Strait sill has been running not for a human lifetime, not for a few centuries, but continuously for thousands of years. That's not a headline exaggeration, that's the plain reality of the system. This is not a thing that switches on and off with the seasons. It has been pouring over that ledge, in the dark, without pause, since long before anyone stood on the Greenland coast, since long before writing, since long before the first person wondered what was under the sea. There is a wider, older story that the whole overflow system across this part of the Atlantic may have been operating for something on the order of millions of years, a figure I'll only gesture at because it sits a step further from the bedrock measurements, and I'd rather underclaim than hand you a number that's firmer in the telling than it is in the science. But even taking only what's solid, the thing has been falling for thousands of years, silently, the entire time our species has existed, and we've known about it for a few decades. Sit with the arithmetic of that ignorance for a second. A structure this large, running for millennia, feeding a current that helps set the climate a huge population lives in, and it was entirely unmeasured until we started leaving wires in the deep and coming back a year later, which is essentially yesterday. Not because it was hiding somewhere remote and hard to reach, it's between Greenland and Iceland, in shipping lane latitudes, in water people have sailed over for 1,000 years. It was hidden not by distance, but by transparency. It was hidden in plain water. The Vikings sailed directly over the top of the largest waterfall on Earth and, of course, saw nothing, because there was nothing to see, because it was falling through the very water holding up their keel. I think that's why I find this so hard to shake. We tend to assume that the great undiscovered things must be far away, the bottom of the deepest trench, the far side of a distant moon, somewhere expensive and difficult to reach. But this wasn't far. This was underneath a well-traveled sea. The reason we missed it wasn't its remoteness, it was our reliance on sight. A whole planet's worth of enormous structure can be sitting right beneath a busy shipping route. And if it happens to be made of the same stuff as its surroundings, if it offers the eye no edge to catch, it can stay effectively invisible for the entire history of a civilization that sailed straight over it. And here, I want to warn you about a trap, because if you go looking for underwater waterfall, you will find a famous, beautiful image that is not this, and getting them mixed up would rob you of the real strangeness. Off the coast of Mauritius, near a headland called Le Morne, Brabant, there's a place that, seen from a plane or a satellite, looks exactly like a vast waterfall pouring off the edge of the island into a deep abyss. The photographs are stunning. They circulate constantly, labeled the Mauritius Underwater Waterfall, and it is not a waterfall at all. What you're actually seeing is sand and silt, pale sediment, being carried by currents off the edge of an underwater shelf and cascading down a steep drop-off into deeper water. From directly above, that moving pale sediment against the dark, deep water reads to the eye as falling water, a trick of color and angle and depth. It's an optical illusion. It's genuinely worth seeing, but it's the opposite kind of thing from what we've been talking about. The Mauritius waterfall is a thing that looks like a waterfall and isn't. The Denmark Strait cataract is a thing that is unmistakably a waterfall by the physics and looks like nothing at all. One is all appearance and no substance. The other is all substance and no appearance. And I think holding those two side by side tells you something quietly profound about how easily the eye is fooled in both directions, how it will see a waterfall where there's only drifting sand and see empty ocean where the biggest waterfall on Earth is thundering silently past. Because that's what the instruments are really for. Not to replace the eye, but to correct it, to catch it in both its errors at once, the false positive and the false negative. The eye off the coast of Mauritius says, waterfall, there is none. The eye over the Denmark Strait says, nothing. There is the largest one on the planet. Left to sight alone, we'd have exactly the wrong map of the world, a spectacular fiction where there's only sediment and a blank where there's a mountain of falling water. It takes the wire in the dark, the year of patient listening, the trace crawling across the page to set the record straight. We are a species learning, slowly and against every instinct, to trust the measurement over the glance. Go back down to the sill one more time and hold the full picture in your mind, all of it at once, the way the instruments would if they could dream. The ridge, 600 meters down, running for hundreds of kilometers between two frozen coasts. The heaviest water in the ocean piled up on the northern side, chilled in Arctic seas, leaning on that threshold. Two rivers of cold, the broad one off Greenland, the narrow jet off Iceland, braiding together at the lip. And then the pour. Millions of cubic meters a second, sliding over the edge and sinking, growing as it drags the surrounding water down with it, plunging kilometers into the deep Atlantic, feeding the cold bottom limb of a current that reaches from the Arctic to the far south of the globe and helps carry warmth to an entire continent's shore. And every bit of that, the mass of it, the motion, the fall, the consequence, happening in perfect blackness, in perfect silence, without a single edge for light to touch, without one witness in thousands of years of running, known to us only because we finally thought to leave a machine hanging in the dark and to have the patience to come back a year later and read what it wrote. And I keep asking myself what it would actually be like to be there, not to see it, since there's nothing to see, but to be inside it. Imagine you're in a submersible, lights burning, hanging in the water exactly at the sill's edge. Outside your porthole, dark water, a few motes drifting through the beam, nothing else, no motion you can perceive. And yet you and your little craft are being carried, along with 3.5 million cubic meters of water a second, over a ledge and down into the abyss, sliding kilometers deeper into the Atlantic, and your eyes would tell you nothing is happening. Your instruments would scream that everything is happening. You'd be falling and you wouldn't feel it, because everything around you falls at the same rate, in the same silence, with no wall of foam rushing up, no roar building, no floor of a plunge pool ever arriving to meet you. Just a slow, total descent through featureless black, the largest fall on Earth registering on your body as nothing at all. There is something almost unbearable about that image to me. To be inside the most violent flow of water on the planet and have it feel like stillness. That's the deepest strangeness of this whole thing, and it reaches further than one strait. Because think about how much of your certainty about the world rests on the idea that the big, important, powerful things announce themselves, that force comes with noise, that size comes with a visible edge, that anything major enough to matter to you would be something you could point at. This waterfall breaks that assumption completely. Here is a force among the largest on the surface of the planet, and it is quieter than a held breath. It has no edge. You could not point at it if you tried. It matters enormously, and it announces itself not at all. And once you've absorbed that, you can't quite trust the quiet again. You start to wonder how many other enormous consequential things are running in exactly this way, below your senses, felt by no one, moving the world while making no sign a human being was built to notice. Turn that all the way inward for a moment, because this is where it stops being about the ocean and starts being about you. Right now, inside your own chest, there's a muscle doing colossal work, beating, pushing blood through thousands of miles of vessels, and you cannot see it, and you have never seen it, and you never will. You know it's there the same way we know the waterfall is there, by inference, by pulse and pressure and the trace on a monitor. Your own heart is, to you, an invisible engine known only through its effects. And it's not just the heart, almost the entire machinery that keeps you alive, the chemistry in every cell, the electricity running your nerves, the slow filtration in your kidneys, the traffic of oxygen through your blood. All of it runs in the dark, inside you, silently, without ever once presenting itself to your eyes. You are, from the inside, mostly a black box. You are as opaque to your own sight as the deep ocean is. The great engines of your existence are hidden in plain flesh, exactly the way the great engine between Greenland and Iceland is hidden in plain water. You spend your whole life trusting instruments, a pulse under the fingers, a number on a screen, to tell you about the parts of yourself you'll never be allowed to look at. So when we finally learned to leave a wire in the deep and read the ocean's pulse, we weren't doing something alien to how we know anything that matters. We were doing the only thing that has ever worked for the important, hidden, powerful stuff, the stuff too big or too deep or too internal for the eye. We were reading a trace, and what makes this particular trace so haunting is the length of the weight built into it. A year. You lower the instruments and you get nothing for a year. No feed, no glimpse, no reassurance that the thing you're hunting is even down there. Just faith that the machine is listening and the discipline to come back. In an age where we expect the world to answer us instantly, where a camera can show us the far side of the planet in real time, the largest waterfall on Earth makes us wait a full turn of the seasons for a single answer, and then hands it to us, not as a picture, but as a column of numbers. It refuses to perform for us. It will not be filmed. It gives up its existence only to patience, and only in the currency of measurement, and never, ever to the glance. And the numbers it gives keep moving, which is its own kind of humbling. I told you the flow was revised, that as recently as a few years ago the best estimate was corrected with better instruments. That's not a weakness in the science, it's the honesty of the science showing through. We are still, right now, learning the size of a thing that has been running unchanged for thousands of years. The waterfall isn't the uncertain one. We are. It pours over that sill with total indifference to whether our arithmetic has caught up, 3.5 million cubic meters a second, whether we've measured it well or badly, growing to 5 million as it drags the deep water down, feeding the cold return of a current that touches the whole Atlantic, warming a coastline by an amount we're still arguing the exact size of, all of it running on precisely as it always has, while a species that only learned it was there a few decades ago slowly, carefully, wire by wire, and year by year, teaches itself to believe in a waterfall it will never be permitted to see. There's one more way to feel the scale of it, and it's the comparison people reach for most often. So let me give it to you with its honesty attached. You'll hear this waterfall described as something like 2,000 Niagaras, as if you took the entire flow of Niagara Falls, that wall of water that deafens you from the viewing platform, that you can feel in your chest as vibration, and stacked up 2,000 of them, all pouring at once over one undersea ledge. And I want you to feel the force of that image while also holding it correctly in your hands. 2,000 times. Niagara is not a surveyed exact multiple. It's an order of magnitude comparison, the kind of figure that gets repeated from source to source, rounding as it travels. What's solid underneath it is the flow we measured, the millions of cubic meters a second, and the fact that this dwarfs any waterfall you could visit by a margin that turns the comparison almost meaningless. So here, 2,000 Niagaras, the way you'd hear someone say a fire, was as bright as 1,000 suns, reaching for the true enormity of the thing, not handing you a number you could check with a stopwatch. The enormity is real. The precise multiple is a gesture at it. Here's a cleaner way to hold the size, one that stays truer to the physics. Picture every river on Earth at once, every river you've ever crossed and every river you never will. The Amazon, the Nile, the Mississippi, the Congo, the Yangtze, and all the 10,000 smaller ones, every stream draining every continent into every sea. Take the entire freshwater discharge of the whole planet's rivers, all of it, the total runoff of the land, and this single overflow between Greenland and Iceland moves water on that kind of order, and moves it continuously, and moves it downward over one ledge in the dark. It's a comparison people reach for again and again, and it's worth reaching for because it stops you from picturing this as a big waterfall and forces you to picture it as something in a different category altogether, a discharge on the scale of a planet's entire river system poured over a single undersea threshold forever. And unlike every one of those rivers, this one makes no sound, cuts no valley you could photograph, and has never once glinted in sunlight. And the thing keeping it going, remember, is almost nothing. That's the part that never stops astonishing me. The difference in density between the water that falls and the water it falls through is small, a matter of a little more cold, a little more salt. If you could somehow hold a cup of the heavy water and a cup of the lighter water side by side, you would not be able to tell them apart. They'd look identical, feel identical, taste near enough identical. The entire waterfall, millions of cubic meters a second, a fall 3 times the height of the tallest on land, a load-bearing pump in the climate of a continent, runs on a difference so slight your senses couldn't register it. That's the deepest lesson the physics keeps teaching. At every scale it appears. A tiny difference spread across a large enough stage becomes an overwhelming force. A whisper of extra density over the width of a strait becomes the biggest waterfall on the planet, And because the difference driving it is so small, the boundary it creates is too faint to see, which is exactly why the largest waterfall on Earth had to stay a secret until we built machines fine enough to taste a difference our own bodies never could. I find there's something almost tender in that. We didn't find this thing by being bold or by going somewhere dangerous. We found it by being sensitive, by building instruments patient and precise enough to notice a difference too subtle for a human being to feel, and then trusting what those instruments told us over what our own eyes reported. The whole discovery is an act of deliberately not believing our senses. Standing on the deck of that ship in the Denmark Strait, every human instinct tells you the water below is just water, calm and continuous, ordinary sea in every direction. And the science requires you to set that instinct aside and say, no. Beneath this ordinary surface, in this ordinary-looking water, something the size of a mountain range is falling, and I know it, not because I can see it, I never will, but because I chose to measure instead of to look. That reversal is the quiet engine under this entire story. You think you already know where the big things are, because you've seen the map, and the map is drawn from what can be seen. But the map of the visible is not the map of the real. The largest waterfall on Earth doesn't appear on any map you grew up with, because the people drawing those maps were doing what we all do, trusting the eye, charting the surface, naming the tall, bright, obvious things, and quietly assuming that what you can't see must not be big enough to matter. And the ocean, patient and silent, held the counterexample the whole time, its single largest cataract, hidden not in some remote trench, but in the plain, transparent water of a well-sailed strait, waiting for a species clever enough to stop trusting its eyes. Hold the shape of the threshold in your mind for a second, because there's a homely image that gets the geometry exactly right. Think of a bathtub, filled slowly past the little overflow drain near the top, that oval slot that stops the tub from flooding the bathroom. Once the water climbs past that lip, the excess just slides quietly over the edge and away. No drama, no splash, a silent, continuous spill for as long as the tap keeps running. The Denmark Strait sill is that overflow lip, scaled to a ridge hundreds of kilometers long. The Arctic keeps making cold, heavy water. It keeps piling up on the northern side, and once it stands high enough against that submarine threshold, the excess slides silently over and down, exactly like the bathtub's overflow, except the tap never turns off. The Arctic has been chilling water and feeding that pile for as long as there's been an Arctic. So the spill never stops. It isn't an event, it's a condition. There was never a first drop, and there will be no last one on any timescale that means anything to us. It simply is, and has been, and goes on being, a permanent, silent overspill at the top of the deep ocean's tub. And that permanence sits strangely against how brief our knowledge of it is. Everyone who ever lived before roughly the end of the last century lived their entire life on a planet whose largest waterfall was running the whole time, and not one of them knew. Every sailor who crossed that strait, every fisherman who worked those waters, every explorer who charted that coast, every person who ever looked out from Greenland or Iceland across that gray channel, the biggest cataract on Earth was pouring beneath them, and they died never knowing it was there. Not because they weren't clever, because it offered them nothing to see. The knowledge simply wasn't reachable by looking, and looking was all anyone had. It took the particular, patient, slightly unnatural act of leaving a machine in the dark and trusting it over the eye, and that's an act only a few decades old, to lift the secret. We are, quite possibly, among the first human beings in the whole span of our species to know that the largest waterfall on our planet exists. That's a very recent piece of knowledge to hold about a very old thing. I think that's what keeps pulling me back to the wire, not the size in the end, and not even the invisibility, but the wire itself and what it represents. Because that wire is the moment our species stopped being purely a creature of the eye. For almost all of our history, to know the world was to see it, or to touch it, or to hear it, to bring it into the range of a body built on the African savanna, to notice lions and fruit and rivers you could ford. And the world, it turns out, is mostly outside that range, mostly too deep, too small, too slow, too faint, too dark. the oceans overturning, the heat crawling through the rock beneath us, the chemistry inside your own cells right now. All of it real, all of it consequential, all of it beyond the reach of the animal senses we were issued. The wire in the Denmark Strait is one small monument to the workaround we invented, the decision to build senses we don't have, to leave them where our bodies can't go, and to believe what they bring back even when it contradicts the plain evidence of our eyes. And what they brought back from that strait is a fact I still can't quite make ordinary in my own head, no matter how many times I turn it over. That in a place the map calls empty water, in a channel people have crossed for 1,000 years, in the dark, in silence, without an edge or a sound or a single witness, the largest waterfall on the face of the earth is falling. Has been falling since before we could write, is falling right now as you hear this, 3.5 million cubic meters a second, swelling to 5 as it hauls the deep down with it. And that we know this not because anyone has ever seen it, and not because anyone ever will, but because we finally learned to leave a wire hanging in the blackness and to wait a year and to trust the trace. So take a breath. Feel it come in. Feel it go. Somewhere out past the edge of everything you can see, in the gray water between Greenland and Iceland, a wire is hanging in the dark, listening. And a river the size of a mountain range is falling through the sea, silent, invisible, exactly as it was 1,000 years ago, and exactly as it will be 1,000 years from now. You will never see it. No one ever will. But it is there, running under the world while you go about your day, holding up a little of the warmth of a whole continent, asking nothing of you, offering nothing to the eye. And that's the part I can't put down. Not that it might stop. It won't, not on any clock that means anything to us. It's that it was there the whole time, enormous and consequential and utterly silent, running in the dark for the entire history of our species, while every one of us stood on the surface, trusting our eyes, certain we'd already found the big things. The largest waterfall on Earth was never hidden somewhere far away. It was hidden in plain water. And all it ever took to find it was to stop waiting to see and start being willing to measure what we cannot. The strangest things aren't always out at the edge of the map. Sometimes they're right underneath the part we thought was empty. Take a breath. It's still falling.